Thank you very much. What we have today is a simple energy meter with IoT interface. We're using ESP32 because of the Wi-Fi capability and also the speed, because ESP32 is 32-bit controller. And we are also using 30 amp relay because our target is for a load that can be around that range. And the LCD we are using here is I2C LCD. And the reason is because anytime you are using a bigger load like this, the on-in and off-in can actually cause the LCD to start resetting. So to prevent the resetting, that's why I'm using the I2C interface. So the communication between the controller and the LCD now is through I2C, that is integrated circuit. And when you come here again, I have a GSM for sending the SMS of the status of the consumption. Anytime you can decide to see your energy consumption by sending status to the SIM card, and it's going to be replying you with the consumption. So we're using SIM 800L, as we all know that it requires like almost close to 2 amp for it to operate. As I'm using this buck converter here, LM2596, I'm going to vary it to 3.7 volt with 3 amp to be able to power the GSM module without stress. And here are my sensors. Here is the voltage sensor, that's the AC voltage sensor, and here is the current sensor. So with the voltage and the current, I can be able to compute the power. And if I have the power, I can compute the energy because energy is power usage over time. So what I have here is that my power supply unit. This is the transformer. It is, you can see it's 15 volt 2 amp. And here is the rectifier. I'm using one N5408 because of its output current up to 3 amp. So with this now, I can rectify and convert the AC back to DC. Here now, we step down 220 to 15 volt. This one will convert AC to DC, and this is just an indicator with 1K current limiting. And here now is I'm connecting two voltage regulator here. That's 7805. I'm connecting two of them in parallel so I can have enough current to be able to power the ESP. So this one here, the two regulators here are the one that power the ESP. Then this buck converter here is the one that power the GSM. So that's the power supply, the transformer, the rectifiers, the filter capacitor, then the regulators, two regulators. This regulator here for powering the ESP, the current sensor, the current sensor, voltage sensor, and the LCD and the ESP. Why this one here is the one that will be able to help me power the GSM module. Don't forget the communication between the GSM module and the ESP is UART, Universal Asynchronous Receive Transmit. And also here is my relay. You can decide remotely now, maybe the energy consumption of your house is actually much and you want to cut off the entire usage. You can just set a command like stop to the GSM module. Once the GSM module receives the command, via this relay to be able to off the load. And this is my transistor here, BC547 and NPN transistor. And this is my flywheel diode. And this is my biasing resistor here, which is 1K. And this is my 4x4 keypad. So in a nutshell now, this is how the system operates. This is the power supply unit. That is the one that will power the circuit. Then these are the sensors here, the current sensor and the voltage sensor and the keypad. And the GSM also serving here as sensor because it can be sending command to the ESP to the GSM. And the outputs now are actually the relay that will be on and off in the load, the I2C LCD 16x2 LCD alphanumeric, and also the GSM also because you can actually at any time decide to want to know the consumption of your load. So basically, this is what we have today. And God bless you. Go to the comment section, ask your question, post observations, and tell me what you feel I can do better to get it fine. Though PCB is the best guy, but you know this is actually a DIY project. So definitely DIY, the beginning is always from zero body. So God bless you and thank you for watching.